Okay, so our first topic for today is physical and chemical changes. And so we're going to look at what is a physical change and what is a chemical change, and how do they differ, and how do we identify when one is happening and when the other is happening. Okay, so on the left you see the ice block melting, and on the right we have fireworks. Now, fireworks are a chemical reaction, whereas ice melting is a physical change. So we're going to see why they're different and how do we actually figure that out for ourselves. Okay, so firstly, physical changes. Remember, it's the ice melting. Physical changes are changes to substances that don't involve changing the physical composition. Okay, so what does that mean? Well, when you melt ice, nothing's actually changed chemically. You've still got water that was a solid, now it's a liquid. So if you want to do a physical change, you can't change what that substance is made out of. So if I could somehow magically change the water into gold, that would be a chemical change, because I've changed that water in the ice into a new substance, which we'll call gold. Just because it's melting, even though it looks sort of like a kind of reaction, all that's happening is that the water molecules are freer to move, and so they'll become a liquid. The composition of that ice hasn't changed. Its chemical composition is exactly the same. So the physical changes that we commonly see are changes of state. So as you can see here, ice melting into water and then water turning into gas. That would be a physical change. All three of them are physical changes. And obviously the reverse processes are physical changes as well. Gas condensing into a liquid, then turning into a solid. All of those are physical changes as well. Changes of density. That's under the assumption that there's no chemical change. So if there's no chemical reactions going on, but for instance, if I took a syringe of air, for instance, and I put a stopper on one end, and I push the plunger down, the gas would start to compress and it would become more dense, but the chemicals haven't changed, so it remains the same chemical. But all that's changed is the density. So that could also be a physical change. The dissolution of a solid. So if I took some salt, sodium chloride, put it in water and dissolve it, I could get it back as salt. All I have to do is remove the water. So that's also a physical change. Now, physical changes in terms of what actually is happening in a physical change, well, what we're doing is we're influencing the bonds between particles, not the bonds within particles. So let's draw a really big water molecule. There's our oxygen, and there's our two hydrogens, okay? Now the bonds inside the molecule are here, which I will circle in red. So these are the bonds inside the molecule. Now if I had another molecule over here, there would be some kind of interaction between the two. Now physical changes only influence this bond between the two molecules, not these bonds inside the molecules. And that's the physical representation of what's actually happening in a chemical change. Bonds between particles, not the bonds inside the particles. And because we're only influencing those between molecules, the bonds between molecules, it makes these changes very easy to reverse. So I can easily turn water into steam and then steam back into water. I can easily turn sodium chloride into sodium chloride solution, then back to sodium chloride crystal. Okay, so they're very easy to reverse. Now, in contrast, we have chemical changes. Now, chemical changes involve altering the chemical composition of the reactants in the system. While physical changes only affected just the state or the way the molecules were arranged, chemical changes actually influence the bonds inside each particle. And so we're actually rearranging bonds in the particle rather than just rearranging particles. Now, typical signs, so when we see a chemical change, remembering that it's now affecting the bonds between the molecules rather than the bonds inside the molecules rather than the bonds between the molecules, what we'll see is when we do a chemical change, we'll often see the evolution of a gas. So a new gas will be formed, and we'll talk about how we define what a new gas is during the reaction. Often we could get a precipitate. So that's how we know if we have two liquids, two complete liquids, and then we pour them together and all of a sudden a solid comes out. So a solid magically appears in these two liquids. Then we know we've got some kind of reaction. because obviously something's happened to get a solid. The absorption or release of a significant amount of heat or light. So we're talking about combustion. Combustion is a reaction and it gives off a lot of heat and light. So that's obviously a chemical reaction. Change in color. So if something changes from one color to another, we know a chemical reaction has happened. Universal indicator, which detects pH changes, is a really obvious example of that. Other ones would include things like hemoglobin. Hemoglobin, the stuff in your blood for biology students. If you expose hemoglobin to air, it turns red. Oxygen. Now, if it's not exposed to oxygen, if there's no oxygen around, it's blue. So that's why your veins are blue, because it's full of blue liquid. Whereas when you cut yourself, it's red, because as soon as you cut yourself, the blood is exposed to oxygen, and so it becomes red. So that's a change in color that you can instantly see. Now, chemical changes involve the breaking of bonds within particles. So as I mentioned before, now we're talking about inside the actual particle. There are bonds, and we're rearranging those bonds to suit our chemical reaction. Now, because we're dealing with those very strong intramolecular forces, that's right, intra, it makes chemical changes very difficult to reverse. So think about burning hydrogen and oxygen. If you burn hydrogen and oxygen, you get very high burning speed and it works well for some cars and things like that, but you get water out. Now, how hard is it to turn water back into hydrogen? And if you think about that, that instantly tells you, oh, okay, yeah, chemical changes are a little bit harder to reverse than just turning ice into liquid water again. Similarly, if you just think of our big global crisis, climate change, CO2 came from burning fuel, and CO2, well, why don't we just use a chemical process and turn CO2 back into something else? And obviously, here's your answer. Chemical changes are difficult to reverse, so it's hard to change that CO2 back into like a fuel or something useful, okay? So that's that. So that concludes today's lesson on chemical and physical changes. We looked at what identifies one from the other, and we looked at how to actually identify a chemical change and what are we actually looking for. Okay, so we'll move on to the question segment now, and hopefully you'll learn something from the questions that maybe you missed in this lesson.